All right. I'm going to start with math practice. Tyler, you're on. You're back from St. Thomas or the islands.
Hi, sir. I am. Got back
Oh
in
my,
yesterday.
the light metals didn't, you guys shut down for the week because you weren't there?
I no, everyone said that it was quiet without me here, so I
One
don't
of the
really know
best
how to
weeks
take
ever, right?
it. Yeah, exactly.
Welcome back. Welcome back. So we got to give him a pass for the homework. Tyler's the only one. Tyler, I'm going to pick on you. But, the key is there's no homework this week. And the idea is that there's 10 kind of homeworks, that you'll be doing. Um, and you don't want to get too far behind. I'm not worried about Tyler. I've known him for a long time, and but I know he was in. Were you in St. Martin last week or St. Thomas?
St. Thomas,
Yeah, tough life, right? Um,
real tough.
yeah, so this is probably the closest to 100% I ever had with in terms of homework. And I want to get right into homework right away, and I am going to use Riyadh's because I think everybody did a great job with it. The idea here, this homework, the objective was to try the tool. One, make a graph, because maybe some people may not have done it before in the past. Two, um, practice going back and forth with the Excel spreadsheet, because that's kind of how we're going to get through all of these. And I picked Riyadh's because I think he probably might have spent the most time on it. I think. Are you on, Riyadh? Well, he's gonna hear the.
Yes,
Oh,
yes,
you
I'm
are.
here.
Okay, good. You are. Yep. So, again, do the graph, and obviously, the idea is that 20 my percent of my expenses are going to represent 80% of my spending, and doesn't didn't work out that way, did it? And I think I love Riyadh's explanation for why that didn't happen. Pretty in depth. Let me get over there. So. In this case, it would mean that 80% of your total spending would come from 20% of your expense types. You have 14 types of expense. If it was exact, about three of them, 20% of 14 would make up the 80%. When you look at your list, the top three expenses, rent, health insurance, and food, only make up about 50% of the total, not 80. So to reach 80%, you need to include more about bingo, right on the nose. That's exactly it. Because a couple of things I had on here was one was miscellaneous. That was a chunk, right? So I probably want to break that down probably into, what is that? And my credit card, what is that? Am I spending at a restaurant? Am I spending it on breakfast, lunch? What am I doing with it? Clothing, and just kind of that's the beautiful part about data is what it conceals is what it exposes is interesting. What it conceals is essential. So yeah, and then I got a whole bunch of tips too in terms of um, fixing my budget, getting my life turned around. Thankfully I didn't get because the alimony's high. Good thing I'm still married. Oof, wow. Any questions on that? I think yeah. Anybody have any trouble with it? Everybody did a nice job on this one. Again, the point was, let's get into Excel a little bit, because we're going to be doing a bunch of different types of graphs and just get a little practice with that. And then also, creating that back and forth with the homework.
I
Anybody
think
have
that
any
it was
questions?
kind of a tricky question because I personally expected it to follow the 80-20 rule. So I was like so confused at first.
I know. I
Like,
saw
how
that
is
when,
it? It's
yep,
not following the rule fully. So,
yeah. It
but
shows
I
you,
appreciate Riyadh doing all this detail because even though, I kind of went through the same thought process, but not in that much detail. So I appreciate the breakdown there.
yeah. I think everybody did a great job on it. The other thing too is, as we get into descriptive statistics, and we're trying to look at, trying to get our processes to follow like a normal bell-shaped curve, because that means they're getting more and more reliable, much more predictable. Well, one of the rules of thumb is, um, and it kind of holds true throughout the course, is going to be, if I'm not getting the information that I need, I just got to get more data, and like getting more data is going to get me to a bell-shaped curve. Probably getting more data here is going to give me a better idea of really what I'm doing with my money. So Yeah, excellent, guys. So that's the homework. Hopefully it was painless. It's designed to be painless. Let's get into the tedium. I mean the PowerPoint. I'm going to send the recording. If you guys have like some of that the stuff that the caffeine drink, or if you have like some espresso, or you want to drink, you know, get a spoonful of sugar or something like, to stay awake through this one. Um, so anyway, let me go through. It's a lot of project management. So we covered this last week. Today's going to be um, the business case. So a lot of project management stuff today. Which I think you might find useful. Hopefully, let me go back one. First, I'm sorry. We'll start out with cost of poor quality. So we're going to go through all of the instances where we bleed. Where we our profit drains. All the examples of things that are in plain sight. Um, that cost us profit and ability to pay people more and the ability to bonus people. We're going to get into some basic Six Sigma metrics, and then we'll get into some project management stuff. And that's what those are there. And then next week is a lot more fun because we'll get into project risk management, but more the tool of failure modes and effects analysis, the FEMA. And then we get into lean. We'll get into the 14 principles. And for a lot of you guys, that'll be a review, I think. But it's definitely a lot more exciting than today. So the cost of poor quality. And the issue is sometimes we look at, just like we looked at that Pareto data from 20,000 feet, in a lot of time, it probably makes sense to figure out, all right, this is what our month looked like. Let's look at what a week looks like. Let's look what a day looks like. Let's look what a shift look like. Let's look at what an hour looks like, and constantly getting finer and finer in take terms of, um, understanding how our business is running. I often see, I think Abhishek, you're on the call from Atlas, like a 1% scrap rate. If I got $20 million in sales, that's $200,000 that kind of I can't pay people with. I can't, invest in something. 4% scrap rate would be 800,000. And that's just scrap, and we're going to go into a whole bunch of different types of um, quality costs. And the estimate is, historically is, on average, 5 to 30% of gross sales is the cost of poor quality. And the only reason it exists is because we don't really think of it that way. We think of it as a cost of doing business, and as in continuous improvement, that's, between the 8 wastes and, trying to develop dashboard metrics, we want to expose these things, so we can, instead of waste, it becomes profit. And especially when you start digging deeper into, not only like process inefficiencies and looking at our processes with a lean eye, but things like hidden factories, which means, hey, this is what the work instruction says, but in that reality, this is what the process really is. And that's very, very common. A lot of times processes don't match up with the way they were designed or how the work instruction looks, and then, of course, there's the common ones like defective products, defects and defectives, rework, cost of inspection. We're going to get into some of those types of things quickly. But it's going to uncover a lot of that for us. It's a symptom, not a defect. It's also, for us lean thinkers, it's an opportunity. When make problems visible in the root of our organizational learning. That's one of the 4 tenets of the Toyota production system that we're going to get into next week. But I want to get that to the surface, because once it's to the surface and visible, then we can get at it. 4 types of cost, kind of break them down into 4 categories: external, internal, prevention, and appraisal. We're going to touch on those each individually. And let's look at it like just a financial opportunity. I don't think there's anything on the exam, on this stuff. Here they are. Here's the 4 categories. Some examples: prevention, cost of poor quality, airproofing devices. Those are all costs, right? Those are all things that we have to invest in: detection and appraisal costs, internal costs, like our quality department. If you think about, basically, lean and the eight waste, things are either um, value added, non-value added, or non-value added but necessary things that we have to do. So no one pays extra because we have a huge quality control department, or no one wants to pay extra because we inspect things 10, 15 times, or because we have to do rework, or because we have to do MRB or anything like that. That's, they're necessary, non-value added, but they're necessary. And then of course there's the external cost of poor quality, like warranty, having to pay twice, complaints, travel, to investigate problems, all stuff like that. And just a quick review, we're going to get into this more next week, but the eight wastes, these are often a source of cost of poor quality, and defects, obviously, but overproduction, making more than we need to ship right now. And I think Hubbard Hall people on here probably love this because we're doing the planes right now. But overproduction is the mother of all waste, causes all the other ones. Waiting. If I overproduce, I got to put it somewhere. It could become, it could become extinct. Customer doesn't want it anymore. I could get damaged in transport. I have to pay people to move it somewhere. Um, the whole nine yards. And prevention costs, again, this is where again, trying to reduce or eliminate the waste and quality control checkpoints. I mean, I see situations where the same thing is getting looked at by five, six people, five, six departments, and then the customer also has to pretend they're the inspector. So there's a whole bunch. And again, when we get into lean thinking, there's a concept called quality at the source, which means we want to make sure that we have good quality as early, and we catch problems as early as possible where it's cheap and not near the end of the line where we've added a lot of labor and overhead to it. And we definitely don't want our customers to be our quality control inspector. Then it gets really expensive. So the earlier we catch defects, the cheaper it is. So detection costs, and then internal costs, maintaining post-production quality check teams, time and tools, and auditing products, costs associated. Think about how much time you spend just doing auditing of inventory, for example. One of the eight wastes. How much time do we spend checking, counting, doing cycle counts, doing ABC counts, correcting inventory, all that. That's all stuff that comes out of our end. The customer, you can't pass it along to the customer. So there's a lot of internal costs of poor quality. And then these are the obvious ones: repair costs, warranty, replacement, returns, MRB, and I think PTA right now for Marcus and Meg and Darnell, and I think Mr. Mattabone's on here. One of the things we're looking at, and Ulbrich Steel too, is converting MRB, where things that don't look good anymore. We have to review them and see what we're going to do with them, like either whether they're going to be rework or scrap. Can we shift that thinking to risk management, where we're looking at the schedule and saying, hey, we had issues with that last five times we did it. What can we do differently? These are all external costs though. And then hard costs and soft costs, two types. Tangible costs that can be traced to the income statement are hard costs, and intangible costs are avoidance, opportunity costs, lost revenue, etc. And then to calculate them, and you guys that know me, I love doing this, but determine the type of waste that are present in your process, estimate the frequency, how often does that happen, estimate the cost per event, and then do the math. And my favorite ones are, I apologize for you guys have heard me talk about this, but if someone walks to the printer 40 steps, and they do it on 3 shifts, so let's say there's 7 or 8 trips to the printer over the course of a year, you're looking at over probably a work week of just walking that you're asking people to do. So like that's just move a printer, right? We've had actual A3s just involved in that. That's just one waste, and then just trying to put math to it, trying to calculate it, And I just love doing it because when I ask the people that are doing the walking, how many times? Well, they may say, I don't know, it varies. But then you say, what did your gut say? Boom. And then if you count it, it usually comes out about right. So, yeah, I know I've done a ton of work in this regard too with Tyler at Light Metals over the years too. But it's good to calculate it and then make your improvements and then measure it again. So let's get into some metrics a little bit. There's a bunch of metrics. Not all of them we're going to cover today. Ways that we measure performance using Six Sigma tools. All right. We're going to cover things, when we get into mapping, like tack time and cycle time and process capability. That's going to be coming up in a few weeks. But let's get into some basic ones. One, how do we define a quality product? So it's a good unit, one that passes inspection. Duh. And scrap is something that the output are defective and cannot be reworked. So scrap means I can't do anything with it. I gotta dispose of it. And rework is they're not acceptable initially. We do something to it, and then it gets good. An opportunity is any point during a process that we can inspect for pass fail. We might have a bunch of checkpoints in our process. There could be multiple opportunities, for a long process. A unit is a deliverable that's produced by our product. And then this one here, the last two are ones that we're going to be using when we get into control charts. A defect is any opportunity that's unacceptable, and a defective is a part that has at least one defect. So a defective unit could have more than one defect. I don't know if Craig's on here from Albrecht. I know he's the one marketing guy. But I think there's also not defectives in terms of non-counting things that we count instead of measure. Like most of us are thinking about measurements, but also another part of Six Sigma is things like things that we can count and also having defective and defective. So a couple of units we'll talk about quickly. One is DPU, which is defects per unit. How many defects do I have on a unit? It's the basis for calculating defects per million opportunities or yield, which we'll cover in the next few pages. And DPU is simply defects divided by units. So if I have 65 defects for every 598 units, it's 65 divided by 598. Quality people, bear with me. I know you think about this all the time. And then DPMO is defects per million opportunities. We're going to take that number basically and multiply it times a million, because when we get to Six Sigma and we only have 3.4 defects per million opportunities, if I didn't multiply times a million, then the number would be 0.00034. So it just helps with the resolution and the measurement. The closer, the better you get, then we start talking about defects per million instead of defects per 100 or defects per 1,000. That's the only significance of DPMO. Yield and first time yield. So yield is the percentage of units that are free of defects. It's a percentage of met commitments over the total number of opportunities. First time yield is how many quality units that I can get divided by a number of total units going into the process. Nothing on the exam on this. You guys are saying, what the heck's on the exam? You keep saying that. These first couple of weeks are just kind of setting the stage for the real fun. So here's an example of first time yield. I have a process that has 3 parts of it, A, B, and C, A, B, C, and D. I'm sorry, 4 parts of it. I pump 100 units into it, and it goes through the first step, and I get 90 good ones, so I lost 10. So the first time yield for a process A is 90 out of 90 divided by 100, or 0.9. And I take those 90 and it goes into the second step, and then I get 80 out. That's good. Then I get 80 out divided by 90, 0.889. I take those 80, go into step 3, and I only get 75 out of that. And then et cetera, all the way to step 4, where I got 75 that go in and I get 70 left. All you do is you take that 0.9, 0.889, 0.93 times 0.9333, and I'll end up getting a first time yield of 70%, 0.7000 for my process. Even though, hey, you know what? My first time, let's say my first process is 90% yield. Overall, going through the whole process, I get 70. So plenty of room for improvement there. Throughput yield, TPY, it's used to measure a single process only. And quality rate or first pass yield, it's the number of units that pass through a process and don't have to be scrapped, rerun, retested, returned, or diverted into an offline repair area. And it's calculated by dividing units entering the process minus the defective units by the total number of units entering the process. Nothing on the exam on this, so just sit back, relax, take a nap. Um, Roll through throughput yield, it's the probability. Now getting interesting. That a single unit can pass through a series of processes defect free. So that's kind of useful, and that's why, because I want to know how robust my process is. And this is an example of that, of a RTY. I calculate the first pass yield for each step and then multiply those together. Very similar. More process terms. When we get into the mapping, especially the value stream mapping part of your program, cycle time is the time required to complete one cycle. Takt time is available production time divided by the rate of customer demand. That would be seconds per part, minutes per rack, seconds per carton. It's time units divided by demand. And takt time is reported in time. And you're going to see that as we get in. For those of you who've done value stream mapping already, we're going to have a review of it. Single piece flow. One product proceeds through various operations without interruptions or scrap all the way through. And the things that interrupt that one single piece flow, of course, are the 8 ways. And then standard work, it's a precise description of each work activity, cycle time, takt time, work sequence, materials that I need, inventory. All right. More project management basics. The process of defining, planning, organizing, managing, leading, securing, optimizing resources to achieve a goal. And it's the application of knowledge, skills, tools, and techniques to meet project requirements. My PTA people are deep into this right now with like 3 or 4 projects going on. A project plan is a crucial step in project management for achieving a project's goals. It's a formal approved document. There's task schedules and costs involved. And there's kind of a breakdown of different parts of a project plan. Again, this is a flyover for project management, but a statement of work, a work breakdown structure. We're going to use an example of building a bicycle, a resource estimation plan, a schedule, a Gantt chart maybe, a budget, communication plan, which is probably one of the most important parts of it, and then a risk management plan. So the statement of work gives us the scope, establishes expectations, identifies technical requirements, provides guidance on materials that we're going to use, establish timelines, things like that. So it's basically an introduction of what the project's going to be about. And the work breakdown structure is decomposing the project components into small logical bodies of work. And I'm going to, instead of going through and reading this, I'm going to get into an example here, which I think spells it out nice. Level 1 of the work breakdown structure is my bicycle that I want to build. Level 2 is the frame, the wheels, and the brake system. And then level 3 is taking each of the frame, the wheels, and the brake system and breaking them into smaller tasks. Resource estimation. What am I going to need to build a bicycle? So largely taking all the level 3, 1.11, 1.12, etc. What do I need for parts? How many? What's the cost? How many do we have in inventory, and who's responsible? Looks like John, Kathy, and Lisa are responsible for all of this, whoever they are. And a schedule. One way to do a schedule is with a Gantt chart. Largely it's taking building that bicycle, getting each of the tasks. I'll tell you, one of the most fun things I have one of my customers is in construction, and being able to take say a 20-week construction project and do a Gantt chart with it, and then doing what we call a pull plan. So apply some lean thinking to the project and it can go from 20 weeks to take down to 12 or 14 because you could overlap a lot of tasks. Very similar to what Darnell's doing and Mr. Mataboni, in terms of looking at what are all the things that can be done simultaneously when setting up a machine, because they're spending a lot of time thinking about setups right now. Gantt chart. And then a financial plan. What do we want to spend? And again, the beauty of A3 is a small, so there's not a lot of budget involved. But if you're working on a big project, there might be some travel, some expenditures, some acquisition of some materials, some capital investments, whatever. So that's all part of the project management plan. The communication plan is always the most important, I think. Making sure that everybody is up to speed and what's happening. I think more people leave companies because they don't feel like they're being communicated with than poor pay I think it's one of the top reasons usually. If you don't communicate with your employees, then that void is going to get filled. That void of communication is going to get filled usually with grapevine stuff and it's not good. So just like anything else, we want to have a plan for how we're going to communicate to everybody what's happening, who's doing what. And that also gives us an opportunity to celebrate, the genius that exists in our business. The risk management plan, we want to try to, and we're going to get into this a little bit more next week when we get into the FEMA. But largely it's how do we identify risk before it happens? How do we mitigate it? And that's a tool that we're going to use, one of my favorite tools next week. But you do that with your project, take a look at it, especially if the project is like in the case of this setup reduction one, that the PTA people that started January and probably going to go through most of the year. Well, what are the things what are the risks, of it not being successful? And you want to try to identify those early and you and mitigate them, put in steps to make sure they don't happen. So very important, risk management. And then planning activities, advantages, of having a plan. We can organize and communicate. We can link our tasks and subtasks. We can look at alternative solutions. Keep everything kind of the scope, not too much scope creep. Effective communication with all of our stakeholders. We could define our management reviews, make sure they're happy. And then a monitoring system, a mechanism, so the project, you don't find out near the end that you're behind schedule. And a little bit more on project management, the business case. So the MAC itself, is part of the project charter. Those are the steps we're going to take during the project. First, we're going to define it, then we're going to measure it, then we're going to analyze it, then we're going to improve it, and then we're going to control it. The purpose is to provide vital information, quick and easy. So it's a scope, who's on the team, who can make decisions, who's leading, and how do we know if we're winning? How do we know we're doing okay? And there's a template for it, where it's all broken down, nice and neat. You can download that. And just kind of, failure to plan is a plan to fail, I guess, or put another way, measure twice, cut once with our project. Should have a title and a leader. And its business case is the quantifiable reason why it's important. I'll give you a couple of examples on that. Business case helps shine light on problems. Problems are our best friend. It's continuous improvement people. My hero, Taichi Ono, we're going to talk about next week when we get into lean. No problem is problem. Every business in America has problems. I wish it wasn't the case. Yep. And the problem statement and objective, we're going to have a properly written statement that has an objective statement woven into it. So we want to have no question as to what the current state or the goal is. And the gap should be declared. It's the difference between today and you guys that do A3, it's very common, current condition and target condition. And it should be in numbers. It should be in data, not just words. And for example, these are example of a problem statements. Process defect rates are 17%. We want to be at 2%. There's a gap of 15, which costs us $7.4 million. The goal is to reduce this gap by 50% before November 2023, putting process defect rates at 9.5 and saving $3.7 million. That's a really good problem statement. Process cycle times, 64 minutes. However, production requirements, we need to be at 48 minutes. This is really a good lean problem statement because it's time, lean is time management. It's estimated to cost the business about $296,000. The goal is to reduce the cycle time by 16 minutes by the end of 2022 and capture all of those $296,000. Those are good, with some numbers in it. Those are good problem statements. So metrics, another key element, measure success is absolute. They give clarity. They establish whether we want, how we did at the end of the day. They establish a baseline or a starting point. And, for Six Sigma, this is what it is. Six Sigma is about data and statistics and numbers. And I put one of my favorite quotes that you guys saw last week on there. We have a primary metric. It's the generic term for the most important measure for success. A primary metric is a must for any project, and it should not be taken lightly. It needs to be tied to the problem statement, measurable. We can express it with an equation and align it to our business objectives. We want to make sure we don't want to wait till the end of the year to check it. We want to check it as often as we can, using tools like, run charts, control charts, things like that. And we want to validate it with our measurement systems analysis, which we're going to get into in the measure phase. We'll get into MSA for a week or two. One example, primary metric, at my company, Duraflex, was we want to increase sales by 15%. That was a primary metric. But little did I know, I was not as smart as I am today, I don't think. You have to have a secondary metric also. Because without the secondary metric, that's the things that we don't want to change while we're still getting our 15% increase in sales. So you guys could just imagine if I told a very competitive sales force that our goal for, I don't know what year it was, 1941, I don't know what it was. We want to increase sales by 15%. Well, guess what happened? They did it. Woohoo! But discounting was like up 50%. We're selling to anybody that had a pulse instead of making sure that they were credit worthy. So our accounts receivable went way out of whack. We were selling to people that maybe shouldn't have been doing floors. So our warranty costs went up. So we always got to make sure that we have a secondary metric that goes along with the all beautiful primary metric. It's your beacon. It's the reason for our work. But we also want to make sure that if we're an example below to another one, we want to save energy in the office building, but we also want to make sure that there's comfort and functionality. Because we could turn off the lights and the heat and save a lot in oil. But those are elements of a good project charter. Scope. The stakeholders are identified. Approval authorities are identified. Review committees, risk and dependencies, project team, etc. Let's get into cost benefit analysis a little bit. And we want to kind of, as you go through a project, it's updating those or, reporting on those as you go through each phase: define, measure, analyze, improve, control. Most of the Six Sigma projects that were really, really popular back in the day, when some companies, that was all they did for continuous improvement. The projects would last a long time. So at the end of the define phase, it would be a very formal kind of a closing. And part of it would be, updating the cost benefit analysis and, keeping everybody up to speed on how things are going and whether it's still going to be profitable. Are we still on target? The whole 9 yards. And cost benefit analysis, direct revenue increase, waste reduction, operation cost reduction, quality and productivity improvement. These are all examples of cost benefits. Employee satisfaction improvements, customer satisfaction improvements, and then a whole bunch of different types of costs there. ROI, trying to figure out what's the return on investment of a particular effort. Total benefits minus total cost divided by total cost times 100. And see what our ROI is. Ta-da! Oh my God, that was fast. 35 minutes. Woohoo! I'm glad. That was the most boring one, right? Whew.
No.
Sorry about that. I do have the recording. I'll send it to you. There's no homework. So we'll be back together next Monday with a much more exciting lean part. There will be a little bit of homework with that. Hope everybody likes that. I'm glad I kept the boring one at 35. Last year it went 56 minutes because I looked at the video. So, whew, you guys got off the hook. Have a great
Thank
Monday. Any questions, guys?
Nope.
No,
All
we're
right.
good.
See you guys.
No.
Have a great afternoon.
You
You as
too.
well.
Thanks, Bill. You
You too,
too.
Bill.
Bye.